Hey everybody, in this recording, we are going to do, we're going to do a verify the identity of this example, sine 3x equals 3 sine x minus 4 sine cubed x. So you already had a guided example quite similar to this, and I did give a lot of advice to a lot of students on how to work this one out. And I'm going to kind of get right to the point here. And if you still have questions, you're going to have to make sure you either ask or go back and compare it to the guided example with cosine 3x, similar concept, okay? So we don't have anything specifically for dealing with something like a 3x, which might be looked at as a triple angle. But we do know how to deal with an angle sum, and we do know how to deal with x, a single regular angle, and we do know how to deal with something like 2x, which is a double angle. So I'm going to rewrite first my left side, because I'm trying to verify it equals this right side. I'm going to rewrite it first as sine parentheses x plus 2x. That is equivalent to sine of 3x. Next thing I'm going to do is I'm actually going to apply my angle sum identity, sine alpha plus beta. I have this rule, sine alpha cosine beta plus cosine alpha sine beta. Everywhere I have an alpha and a beta, I'm going to swap in an x and a 2x. You should really have these memorized, and you really shouldn't have to look at them. I'm not going to write it on the right, because every step of the way, you should just keep the right side as what it originally is, because our goal is to change the left until it equals the right. Maybe you chose to change the right until it equals the left. I think that the way I'm doing it would be easier. So doing what I just described, sine alpha cosine beta plus cosine alpha sine beta. Alpha is x and the beta is 2x. So there we go. That's my third step, equals still 3 sine x minus 4 sine cubed x. Keeping it moving. Next thing that we're going to take care of is, if you look, I have on my right side, everything has just an x. It's all just a single angle. So sine x, cosine x, you're cool. You can stay. But hello, 2x, you're not in my answer. You are what we call a double angle. So I need to go and use some double angle identities, which are on my reference sheet. So sine of 2 theta or 2x or 2 anything, we only have one option. It equals this, and it's just theta theta or xx. So that's good. I could fill that in. No other option for that. Cosine 2x or 2 theta, on the other hand, I have 1, 2, 3 options. I could either use cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. Again, to go over where the 3 of these come from, you want the derivations, which are available at the lesson intro of the double angle identity lesson, that section, that unit. So I have 3 options. If you are completely unsure of which one to use, I always use the first one to start. However, if you wanted, to narrow it down and kind of get a better idea of what it, should go in there so that you're most efficient. If you look over here again at the right-hand side, another thing that you should take note of is the fact that I only have sine on this side, okay? Just like I only have x, I also only have sine. I don't have cosine anywhere on this side. That means if I could, why wouldn't I pick for cosine for my 3 options here, the third one here, the one that only has sine in it, just to get me one step closer. Will it really make that much of a difference? Maybe, maybe not, but we do our best. So I'm going to fill in 1 minus 2 sine squared x. All right, that's what I filled in for my cosine 2x. And then we said sine 2x double angle. I only had one option, 2 sine x, cosine x. Okay, so that is what we have right over there. Okay, so this sine of 2x got replaced with that identity. We had one choice and only one choice. And this over here, cosine of 2x got replaced with 1 minus 2 sine squared x. Okay, other guys, they just sort of stayed the same. Now we continue. I got to open this up, clean this up. I want it to look like this. So I don't want these parentheses to stay. Let's open them up. Here, this parenthesis has a minus sign in between. This is technically going to be distribution. Sine times that, sine times that. This over here is just all being multiplied. So you're not really distributing as much as you're just mushing it up, multiplying it, consolidating it, cleaning it up. So sine times 1, sine x, 1 sine x, whatever. Minus 2, this coefficient's 1, so it's a 2 in front. Sine times sine squared, x times x squared, right? That's going to be sine cubed x. There we are, distributed, okay? Plus, this plus sign is the same one, carrying down the whole time, okay? Cosine times 2 times sine times cosine squared. Well, cosine times cosine, that's going to be cosine squared. So you're going to have 2 sine x, and then you're going to have cosine squared x. There's my equal sign in the middle again, and I'm still 3 sine x minus, I'm trying to kind of keep it neat on this side so it doesn't look, you know, like I'm not keeping it the same every step of the way, okay? Now, next up, we are closer. We have all x's, x, 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 right? No double, no triple angles. All we have are x's. What else? And I'm just going to kind of cover up a little bit above here because I don't want it to be distracting. I want us to just focus on the step that we're on right now. So we're just on this step and we're only focusing on this step, okay? X, 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 x. We're cool with that. X, x, yes. Sine, 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 cosine squared, sine, sine. Interesting. So we need to deal with this fact that on the left, we still have cosine squared floating around. Well, let's look at my handy dandy identities. Let's go way back to our Pythagorean identities. Here we have sine squared plus cosine squared equals 1. I can swap cosine squared out for 1 minus sine squared, because if this is a fact or an identity true, any arrangement of it is still true. So I'm going to swap out my cosine squared for a 1 minus sine squared. Next step, we have sine x minus 2 sine cubed x plus 2 sine x, filling it in, 1 minus sine squared x equals, sorry, I'm squeezing. Like I said, I wanted to keep this lined up. 3 sine x minus 4 sine cubed x. Home stretch. Again, if you have to cover up the steps before it so you don't cloud your judgment and get like confused and overwhelmed, then do it, right? Just do that. I am going to distribute 2 sine x into these parentheses. I do have a minus sign, either a plus or a minus sign. That means we distribute, we give that to each item inside. These are kind of just going to stay in the next step and come along for the ride. Sine x minus 2 sine cubed x plus 2 sine x times 1. Well, that's just 2 sine x minus 2 sine x times sine squared x. Well, that looks very familiar to a step we did right over here. And we got that over there, right? Very, very familiar. Same technique, same style of a problem. So we're just going to continue with that. So we will get 2 sine cubed x equals 3 sine x minus 4 sine cubed x. Okay? Again, maybe we don't want to cloud our judgment. We kind of cover it up, focus on what we're dealing with. We want this on the right. If we look carefully at my left-hand side over here, if we look carefully, you're going to see some like terms. Sine x, this is sine cubed x. Sine x, this is sine cubed x. Just combine like terms. We call it a day, and it's going to be amazing. We'll be done. Sine x plus 2 sine x is, you got it, 3 sine x. Bing, 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 bing. There it is. Minus 2 sine cubed x minus 2 sine cubed x is minus 4 sine cubed x. And guess what I had over there? Minus 4 sine cubed x. Winner, winner. Chicken dinner. check. Now remember, the whole point of these problems is like to show the work, how to verify it. So you need all of those steps, not just these 2 lines on the bottom. You kind of show everything, but you have to understand how I got there because this stuff doesn't fall out of the sky onto your paper. So you want to make sure you understand how to get from one place to the next. If you need to watch this over again, I definitely suggest you rewind and watch it from the start, or, you know, come back, try it over 2 days from now and see if you could still do it, and recreate this. And sometimes in college, I would memorize how to do a problem that I didn't fully understand. I just would do it over and over and over again. And there were times that I would memorize these big problems, write them on my paper on an exam, and then apply that to another problem. And I remember on a final exam, I think it was Calc 3, when finally the thing I memorized made sense in the middle of the exam. I was like, I get it. I finally get it. It just took me like 2 years, but I got it. I got it. And you'll get there. Okay. So you got it. Thumbs up. Don't got it. Thumbs down. And I will see you in the next example.